Welcome to lesson 3.2. So in 3.1, we learned about the relationship between the different angles with a transversal. And so now we're going to talk about how we can look at that relationship, not only give it a name, but look at if it's equal, if it adds up to 180, or if there's any way that we can find some different angles from that, some different measures of those angles. So let's start off with this corresponding angles postulate. So it says if two parallel lines are cut by a transversal, then each pair of corresponding angles is congruent. So first off, let's remember what corresponding angles mean. All right, so remember, corresponding angles are angles in the same position. All right, if you remember that angles in the same position, when we say same position, we are looking at, in this group of 4, where does the angle lie? In this group of 4, where does the angle lie? All right, so we start with the top left. All right, so you see number 1, angle number 1 is in the top left, and angle 3 is in the top left. So those two would be corresponding. Similarly, 2 and 4, 8 and 6, and 7 and 5. And so now this postulate tells us that if these two parallel lines are cut by a transversal, then the corresponding angles are actually congruent to each other. So for example, let's say if the measure of angle 1 was 100 degrees. All right, well, because angle 1 is corresponding to angle 3, then that means that the measure of angle 3 would also be 100 degrees, right? Oh, and what's cool about this is we can actually find all 8 angles from just knowing one of these angles because we know their relationships. So if angle 1 is 100 degrees, oh, well, we know it's vertical to angle 7, so angle 7 is also 100 degrees. Well, and 7 and 8, they're a linear pair, they're on a line, so they add up to 180. So if 7 is 100, 8 is 80. Oh, and look, angle 8 and angle 2 are vertical. Therefore, angle 2 is also 80. All right, well, we just said angle 1 was 100 and angle 3 was 100. Oh, but now angle 3 is vertical to angle 5. Therefore, angle 5 is 100. Oh, now look at 4 and 5. 4 and 5 are linear pairs, so they add up to 180. So if angle 5 is 100, angle 4 is 80. And angle 4 is vertical to angle 6. Therefore, angle 6 is also 80. So even though we only knew one of those angles, we can find all other 7 of those angles, which is pretty cool with this. So corresponding angles, so I kind of want you to let's make a T-chart here of which angles are going to be congruent to each other and which angles are going to be supplementary. If you remember, supplementary means they add to 180. All right, cool. So we just said corresponding angles are equal. Also, our alternate interior angles are congruent. Our alternate exterior angles are also congruent. The only type of angles that we had just talked about in 3.1 that are supplementary are going to be our same side interior or consecutive interior. You can call them either one, but those are the only ones that are going to add up to 180. All right, so again, you can kind of look at that and see that that's true by just looking at the picture. So for example, if angle 1 and angle 3, right? Angle 1 and angle 3, if you look at that, they're both obtuse. So then in your head you can think, oh, they're both obtuse, so they're probably equal to each other. Now if you look at angle 2 and angle 3, you'll see that angle 3 is obtuse, but angle 2 is acute. Therefore, you know that those can't be equal to each other. Therefore, they're going to add up to 180. So again, this T-chart right here is going to be super helpful to you when you're looking at angles. You can kind of remember which ones are going to be congruent and which ones are going to be supplementary. So let's look at an example of this. All right, cool. So in this figure, they tell us that the measure of angle 11 is 51 degrees. So again, we always want to label what you have here. I'm going to give you just a second to draw out this set of angles. So you got 10, 11, 12, 13, 14, 15, 16, and 17. Again, we have 8 angles. By the way, we know that line X and line Y are parallel because of these little arrows here. So if you ever see filled in arrows like this, that means that those two lines are parallel. All right. So back to the problem, we have the measure of angle 11 is 51 degrees, and we are trying to find the measure of angle 15. So first step always is to classify the pair. What kind of angles are those two angles? All right, so we're going to classify that pair. So if we look at 11 and 15, okay, well, kind of like we did last time in 3.1, are they both interior? No, 11's exterior, 15's interior, okay. So if they're not, then we have to say, okay, well, could it be corresponding? Are they in the same position? Well, if you look at angle 11, it's in the top right, and angle 15 is in the top right. Therefore, they are corresponding angles. All right, so step 2 after you classify the pair is you determine the relationship based on your T-chart. All right, so now we have corresponding angles, so go to your T-chart and figure out, are they equal or do they add up to 180? So based on your T-chart, you'll see that they are equal. Therefore, if angle 11 is 51, the measure of angle 15 is also 51 degrees. And don't forget your degrees, because remember, angles always have a degrees at the end. All right, so now I'm going to let you do the next one. If the measure of angle 11 is still 51, what is the measure of angle 16? Okay, so still follow these 2 steps. Figure out what kind of angles are angle 11 and angle 16. Go from your T-chart. Figure out which one of those 4 are these type of angles. From there, then you're going to determine the relationship, figure out, are they equal or do they add up to 180? And then you'll be able to find measure angle of angle 16. So now you can find this on your own. All right, let's do another one here. So now in this figure we have A is parallel to B, so I want to remind you that those 2 lines there, that means is parallel to. So line A is parallel to line B, and the measure of angle 18 is 42 degrees. And we want to find out what the measure of angle 22 is. All right, still same steps. We're going to classify the pair, figure out what kind of angles we have, and then we're going to determine their relationship. Same steps. All right, sweet. So now hopefully as you're doing more of these, you can easily see that these 2 angles are again corresponding angles because they're both in the top left here. All right, so we're classifying the pair. They're corresponding. Then I go to my T-chart. Are they equal or do they add up to 180? And we see corresponding are equal. Therefore, if the measure of angle 18 is 42, measure of angle 22 is also 42 degrees. All right, and now we're looking at 18 and 25. 18 and 25. And I'm going to let you follow your steps and figure out what the measure of angle 25 will be. All right, so now we get a little bit trickier. We got multiple lines going multiple ways this time, but again, don't let that scare you, right? Remember, just go step by step, use only the lines that you need at one time, cover up the rest, okay? So this says the diagram represents the floor tiles in Michelle's house. If the measure of angle 2, right here, is 125 degrees, all right, so I'm gonna label that. They want me to find the measure of angle 3. All right, so again, I'm only looking at angle 2 and angle 3 right now. So I see which lines can I cover up so that I don't get confused. Okay, well 2 and 3 are on this middle line right here, and they're on this line and this line. So those are the only 3 lines I need. So I'm going to cover up this line and this line so I can see it a little bit better. So if I were just doing this in person, I like to just cover it up with my hands. But for this sake, I can just color it in, and so we can just look at what we need to. Okay? So still the same thing as we've been doing, our 2 steps. So step 1, of course, is to classify. So let's classify angle 2 and angle 3. All right, so are they both interior or are they both exterior? We're like, hey, they're both interior because they're inside the 2 lines, okay? Then we're looking at, are they on the same side of the transversal or are they on opposite sides? Well, 2 is on the left, 3 is on the right, therefore they're on opposite sides. Therefore, they are alternate interior angles, all right? Then go to your T-chart, and you're going to determine the relationship. All right, so now I look at my T-chart, and I see that alternate interior angles are congruent to each other. Therefore, if angle 2 is 125 degrees, I know that the measure of angle 3 is also 125 degrees. All right, so that was not too bad. Now we're going to do the same thing for the angles down here at the bottom. So let me clear all of the annotations out so you can see it a little bit better now. There we go. All right, so this time we're looking at measure of angle 2, and we're looking at the measure of angle 4. All right, so we got to figure out here, do these have a relationship first? And that's what we've been doing. And if they don't, then we got to figure out how could we get to a place where we would know what their relationship was. All right, so let's look at 2 and 4. So again, let's look, are they both interior? No. 2 is on the interior. By the way, y'all, again, we're not using this line or this line because 2 and 4 are not using those lines at all. Okay, so now I'm just looking at 2 and 4. One's on the interior, one's on the exterior, so it's not one of those. They're not in the same position, so unfortunately it's not those. So I gotta find a different method to figure out what the relationship is between 2 and 4. But I can use those things that I already know to get there. All right, so a couple ways you can do this. So let me just start, I always like to start off with the first angle. So angle 2 here. All right, well, let's think here. How could I get from 2 to 4? So if I want to move closer to 4, I start at 2, and now let me see, hey, let me think. 2 and 3, do they have a relationship with each other? Well, they're both interior, and then they're on opposite sides of the transversal. Therefore, they're alternate interior angles. So 2 and 3 are alternate interior. All right, and I go to my chart, and I see that alternate interior angles are congruent to each other. Therefore, if angle 2 is 125 degrees, I know that angle 3 is also 125 degrees. Okay, so I'm getting closer to angle 4. Now I gotta look at, angle 3 and angle 4. Let me think here. What kind of angles are those? Well, angle 3 and angle 4 are on a line. Therefore, they are a linear pair, something we learned back in chapter 1. If you remember, linear pairs are supplementary. Again, that means that they add up to 180. Therefore, angle 3 plus angle 4 is going to be equal to 180. All right, so if angle 3 is 125 degrees, I'm going to subtract 125 from 180, and that's going to give me 55 degrees. And therefore, the measure of angle 4 is 55 degrees. So not too bad there. Again, y'all, even if there isn't a specific relationship between the two angles, you can use the relationships we know to get to that place so you can find the measure of that angle. All right, and of course, you know, we got to throw in some algebra here, but again, same rules apply. Don't worry about the x's, same rules apply. So let's see here. So this time we have two pairs of parallel lines. We have line M is parallel to line N, and line P is parallel to line Q. All right, so let's start off with the first one. So we're looking at, it says the measure of angle 5, which is right here, is 2x minus 10, and the measure of angle 7 is x plus 15. All right, so first off, can we classify those angles? So again, we're only looking at angle 5 and angle 7, so let's cover up everything we don't need. So again, let's not look at anything over here. Let's just look at angle 5 and angle 7. All right, I gotta first off see if I can classify them. All right, so if I classify them, I'll see that they're both in the same position, therefore they are corresponding, right? And then we go to our t-chart. Now that we know that they're corresponding, we're going to determine that they are congruent because they're corresponding. All right, sweet. So 5 and 7 are congruent to each other, therefore we can set them equal. So all I'm going to do here is I'm going to take 2x minus 10 and set it equal to x plus 15 and solve. All right, so now we just got a simple algebra problem. So I'm going to add 10 to both sides. Now I've got 2x is equal to x plus 25, right? Then I'm just going to subtract x, and we get x is equal to 25, right? And they told us just to find x, so this would be our answer. If you want to check your answer, which I always advise doing, you can plug that x back into both of those angles to make sure that angle 5 and angle 7 are actually equal to each other. So for example here, that would be 2 times 25 minus 10. 2 times 25 is 50. 50 minus 10 is 40 degrees. All right, so they're saying angle 5 is 40 degrees. Now for angle 7, then I'm just going to plug it in right here for x plus 15. So I'm just going to say 25 plus 15 is 40 degrees. And look, those two are congruent. So that means we're right. And therefore, x is equal to 25. All right, so this next one you're going to do on your own. But I am going to kind of give you some good thinking to start out your process here. All right, so again, now we're looking at angle 4 and angle 8. All right, so I always like to highlight what I'm looking at. Angle 4 and angle 8, cover up anything I don't need. So I don't need this line at all over here. So again, let's just look at just what we need. All right, follow your steps there. What kind of angles are angle 4 and angle 8? And if they aren't a specific type, can we get to a place where we know, again, they're always going to be either equal or add up to 180. So I'm going to give you a second to do that now. All right, and our last problem of the day here is we have multiple angles with multiple variables that we need to solve to find out. But again, following the same process, no big deal here. All right, so let's start off. They tell us first if the measure of angle 1 is 9x plus 6. So I always like to label them if I can. So 9x plus 6 is there. For the measure of angle 2, they have 2 parentheses 5x minus 3. And then if the measure of angle 3 is 5y plus 14. All right, so I want you to notice that we have x's in our angle 1 and angle 2, right? But then we have y's in angle 3. So I want to deal with my x's first so I can solve for that, and then that'll help me get to my y, because can't really do anything if we have an x equal to a y unless you have two equations, which would be harder. So just if you can ever start with something with the same variables. All right, so I'm going to start with my angle 1 and angle 2 because they both have x's. All right, so I'm going to see here, angle 1 and angle 2, can I classify? All right, well, let's see. So if I'm looking at just angle 1 and angle 2, then I am covering up that bottom line here. All right, so I'm going to cover up all of this. I don't need to see any of this right now. All right, now let's look at angle 1 and angle 2. Are they interior or exterior angles? Oh, well, they're outside the two lines, so they're exterior angles. Are they on the same side of the transversal, which, by the way, this time is line C, Or are they on opposite sides? And they're on opposite sides. Therefore, they are alternate exterior angles. All right, now I go to my T-chart and I'm going to determine their relationship, which you'll see in your T-chart, they are congruent. All right, so now I know they're congruent. I can just set these two equal. So I'm going to have 9x plus 6 is equal to 2 times 5x minus 3. And now we got a simple algebra problem. So we see we got parentheses there, so I'm going to start off by distributing my 2. So 2 times 5x, that's 10x, and 2 times negative 3 is negative 6. I'm just going to carry it down my left side, 9x plus 6. And then I'm just solving from there. So plus 6, and that gives me 9x plus 12 equals 10x. And now I just subtract the 9x, and I'm left with 12 is equal to x, which is great. All right, so I got my x now. I have my x, all right? So now let's see if I can use my x to find my y, all right? Well, let's see here. If I can plug in that x, then I can figure out what angle 2 is. So let's do that. So if I plug that in, I'm going to have 2 times 5 times 12 minus 3. All right, well, 5 times 12 is 60. 60 minus 3 is 57. And 2 times 57 is going to give me 114 degrees. All right, so I'm going to clear these annotations so you can see this just a little bit better. So again, angle 2 is 114 degrees. So I'll give it just a second to clear. All right, great. So now we see that angle 2 is 114 degrees, and I want to see if I can figure out what y is. So then again, down here, we just have 5y plus 14. So now I'm just looking at angle 2 and angle 3. All right, so again, now I can just cover up everything over here because I don't need it over here. All right, so let's see. Again, follow our steps. Classify. So let's look at angle 2 and angle 3. All right, are they both interior? No, one's interior, one's exterior. All right, so then are they corresponding? Are they in the same position? Well, look, angle 2 is in the top right and angle 3 is in the top right. Therefore, they are corresponding. Now I go to my T-chart and I see that corresponding angles are congruent. So we're determining the relationship is congruent. Therefore, now all I got to do is say 114 is equal to 5y plus 14 and solve. So from there, I'm just going to subtract 14, and I get 100 is equal to 5y, and divide by 5, and I get y is equal to 20. All right, again, if I want to check my answer to make sure I'm right, I could plug that y back into my angle here, so that I'd have 5 times 20 plus 14. 5 times 20 is 100. 100 plus 14 is 114 degrees. And what do you know? We got the same angle as angle 2, which is correct because we know those are corresponding angles which are congruent. So that is today's lesson. Again, if you can classify those angles and use that T-chart, you are going to be just fine, no matter if you're finding just a number of an angle or if you're solving an algebra. I will see you for the next lesson.